Hey guys, this is the part 2 video for Introduction to Matrices. And if you take a look at number 5, we're asking you to add two matrices. 6 is to subtract. 7 is another add problem. If you look down here with 8 and 9, that would basically be the distributed property, which is really easy. So number 8, so let's take 3 times a matrix. Number 9, take -4 times a matrix. So believe it or not, operations with matrices, the add, the subtract, and the distributed property problems are really super simple. Unfortunately, multiply, and you might think to yourself, oh, multiply, just multiply some numbers together. And not so much with matrices. So if you're looking for the multiplying matrices part, that's going to be in the part 3 video. So for part 2, we're just going to look at something a little simpler. So this first one, I think I'll write it out, and then from here I might shortcut a little bit. But it says to take matrix A, and I'm just going to repeat him just to illustrate. And add matrix B. Now, if you watched part 1 video, there was an equal sign there. So we would have taken the -3 in that upper left and set it equal to whatever I'm about to write. But this time it has a plus sign. So believe it or not, it's that simple. Okay, so we would take whatever's in this row 1, column 1, and row 1 and column 1 and add them together. So -3 and 13 is 10. Whatever is in row 1, column 2, row 1, column 2, the 4 and the 10, and add them together. And they just stay in their position. They stay in that same cell. Row 2, column 1, row 2, column 1, add them up. And that last one, -1 and 31, will make 30. Too good to be true? Well, for once it isn't. And just put the little brackets around. Again, brackets stand for matrices. So yeah, believe it or not, it's that simple. So for B minus A, I'm not going to rewrite them. That's just going to be a pain. You don't have to do that either. Just have to subtract them. Now be careful though. It is B minus A, not A minus B. So I want the B number minus the A number. Now I'll tell you what, you could do this. I'm at least going to write it down. I'm taking the B number minus the A number. So notice I got 2 minuses in a row. So that might be worth writing down, to be honest with you. The upper right corner, the B number is a 10 minus the 4 is in matrix A. So again, just make sure you're starting with the B number, which is -7, subtract a -5. So see how writing it down actually might pay off. The B number is 31 minus the A number, which is -1. So a lot of math teachers make you take time to write that out. Then you just go back and do the problem. Well, 2 minuses in a row makes a plus. So I get 16 in that corner. 10 minus 4 is 6 in that corner. 2 minuses makes a plus. -7 and 5 makes -2. And for crying out loud, yes, use a calculator. 2 minuses makes a plus. 32. Brackets represent matrices. And that's all you got to do. All right, now, eyeball up number 7 here and see if you can figure out what the problem might be. So we could start off and say, all right, I'm going to add the A number to the C number. That gets row 1, column 1. I could add the A number to the C number. That's row 1, column 2. But oops, where's the third number to add to the third number? So it is possible, ladies and gentlemen, that what they're asking you to do with a matrix is impossible. So find A plus C, nope, can't do it. So undefined, impossible, no solution, can't do it. So if you're going to add or subtract, your rows and your columns better match up. So the fact that we were doing, or A was a 2 by 2 matrix, and C was a 2 by 3 matrix is not going to work because these numbers all have to match, and they do not. Okay, even better news, right? No math to do whatsoever on that one. All right, number 8. Scalar multiplication just means distributed property for all intent and purposes. So again, I'm going to write this out one time. And I'm probably not going to do it again. So I'm supposed to take 3 times a. So putting the 3 up against the bracket still means times. Well, let's see. What was the A matrix? -3 and 4. I'm going to scroll up to find it. And there was a -5 and a -1. So you might be saying to yourself, no, really? It's that easy again? And the answer is yes, it's that easy. So I'm just going to distribute every one of these. So I'm going to go 3 times that guy, 3 times that guy, 3 times that guy, 3 times that guy. So 3 times row 1, column 1 is -9. 3 times row 1, column 2 would be 12. 3 times the bottom left corner would be that. And 3 times the bottom left corner would be that. And that's it. So, number 9, find -4 times C. Am I going to be able to see it or not? Barely. I think we can get it in there. So, hopefully you guys will get the idea without me actually rewriting it. So, it's -4 times the whole C matrix. So, let's see. Can you see that upper left corner is a -6? So, if I go -4 times him, I get a 24. There's a 9 in the middle. If I go -4 times him, -36. There's a -2 on the end. -4 times him. And then repeat. -4 times the second row will give me a 20. -4 times -3 would give me a 12. -4 times 8 would give me a -32. Put some brackets to represent the fact that you're doing a matrix. And that's it for scalar multiplication, folks. So sometimes we might make it a little tougher on you. I'll just give you a quick example. I won't actually do the problem. Let's say we did 6 times A plus 4 times B. So you would do it just like order of operations. You would do a little distributed property on this matrix, a little distributed property on this matrix, and then you would add them together, add all the numbers together like we did on those first 2 problems. All right. I would like to tell you that multiplying matrices like this, if we said, hey, I'm going to take matrix A times matrix B, I'd like to tell you that that's really simple as well, but it's not. So that one you might want to check out if you watch this video. Thanks as always for watching.